10th Physical Science Lesson Structure of Atom. Topic: The Pauli exclusion principle. Pauli is a scientist. He discovered this principle. So according to Pauli scientist, no two electrons of same atom contains all the four quantum numbers same. So every orbital accommodate two electrons. So here we see one example, helium. Helium is a element and contain two electrons. So electron configuration is 1s2. So only one orbital is there and electrons are 2 is there. One electron position is upward direction and another one electron appeared as a downward direction. So here we can see the ms values difference. Okay. Next, 4 quantum numbers. Yesterday we learned about the 4 quantum numbers. 4 quantum numbers means n, l, ml, ms. So how many electrons are there in the one orbital? 2 electrons are there. So first electron and the second electron. So first electron, principal quantum number 1 and second electron, principal quantum number 1. L values. So S L values, first electron 0 and S value of second electron is 0. Next, ml values. When L value is 0, automatically ml value is also 0. Okay. So first electron ml value 0 and second electron ml value is also 0. So here we observe the difference between the first electron and the second electron contain the different ms values. Why? Because the first electron shows the upward direction and second one shows downwards directions. Okay. So 1s2 electrons of the helium same value shows in n, l and m1. So here we can see n, l, ml. All values are same for first electron and second electron. But ms value is different. One shows plus 1 by 2. So upward direction electron shows plus 1 by 2 and second one shows the downward direction. It means minus 1 by 2. And electron configuration is 1s2. So upwards 1 and downwards 1 electron. Okay. This is all about the Pauli exclusion principle. No two electrons of same atom contains all the 4 quantum numbers same. So here we observe one ms values are different for 2 electrons present in one orbital. Okay. Second one, Aufbau principle. Aufbau means building up. So what is building up here? Electrons building up in the atoms. So according to the Aufbau principle, electrons are filled first in the lowest energy orbitals, gradually enters in the higher energy levels. So lowest energy orbitals are there and higher energy orbitals are there. So in the atom we find the main cells, subcells, orbitals, electrons. So in the main cell, n is equal to 1, one s subcell is there, and in the s subcell one orbital is there. So each orbital accommodated 2 electrons. So 1 into 2, 2 electrons. So the main cell contains 2 electrons. And second main cell, subcells 2s, 2p. Okay. So orbitals 4. 4 into 2, 8 electrons. It means 4 orbitals accommodated 2 electrons. When we see third main cell, 3s, 3p, 3d subcells are there, and orbitals 9 is there. So these 9 orbitals accommodated 18 electrons. 9 into 2, 18 electrons. Next, fourth main cell, 4s, 4p, 4d, 4f. Totally 16 orbitals are there here, and 16 into 2, 32 electrons are accommodated in these orbitals. Okay. So the electrons are distributed from 1s to 4f. Okay. Next, here we can see the chart, molar chart. This is a molar chart. So in this molar chart, the electrons filling order of atomic orbits. Okay. So how does the electrons filling in the orbitals? Now here we observe n is equal to 1. First cell 1 is there. So first the electrons entering in the 1s. Next electron, n is equal to 2. So second s orbital is there. So next electron, 2p, enters into the 2p. Next electron, third s. Next 3p. Next 4s. Next 3d. After filling 4s, the electron enters into the 3d. But here we observe in the main cell 3, 3s, 3p, 3d is there. After 3d, 4s is there. But in the molar chart, we can observe after filling 4s, the electrons enters into the 3d. Why? Because by observing the principle n plus l, so 3d, n means 3 plus l value of d is equal to 2. 3 plus 2, 5. Next 4s. 4s means n is equal to 4 plus l value of s is equal to 0. 4 plus 0, 4. So 4 is less than 5. Then 4s is a lower energy orbital, 3d is a higher energy orbital. So the electron goes into lower energy orbital 4s, next enters into the 3d orbital. 3d is a higher than 4s. Okay. So like that, the electrons are filling order of atomic orbitals in the molar chart. So here we can see 1s less than 2s, less than 3s, less than 3p, less than 4s, less than 3d, less than 4p, less than 5s, less than 4d, less than 5p, less than 6s, less than 4f, less than 5d, less than 7s, less than 5f, less than 6d, less than 7p, less than 8s. Like that, all the electrons are enters from lower energy orbitals to higher energy orbitals. Okay. Here also we observe first lower energy orbitals are filled, next higher energy orbitals are filled here. Okay. So here first element hydrogen, the atomic number is 1. It means one electron and one proton is there. So the electronic configuration is 1s1. Only one electron is there. So electronic configuration is 1s1. So it means one orbital is there and one electron is there. So the one electron shows the upward direction. Okay. Next one, helium. How many electrons are there? 2 electrons are there. Electron configuration 1s2. So how is in the orbital? One is upward direction and second one is downwards direction. Next one, lithium. How many electrons are there? 3 electrons are there. Electron configuration 1s2, 2s1. So in the first orbital, one electron upward and second one downwards. Next, third electron enters into the 2s orbital. So here the electron shows upward directions. Next one, beryllium. 4 electrons are there. Electron configuration 1s2, 2s2. Next one, here 2 electrons into one orbital and 2 electrons on the another orbital enters. And boron, electrons 5, 1s2, 2s2, 2p1 electron configuration. So 1s orbital filled here with the 2 electrons and second 2s orbital also filled with 2 electrons and fifth electron enters into the p orbitals. So in the 3 orbitals, so one is the electron enters into the first orbital. Okay, so p subshell 3 orbitals are there. So first of the p subshell, so the electron enters into the first orbitals and it shows upward direction. Okay, so all these observing about the Aufbau principle. So this type of questions comes in the examinations. In which of the following Aufbau principle is violated? You observe here. In which of the following Aufbau principle is violated? So 1s2, 2s2, 2p2, 1s0, 2s2, 2p2, 1s2, 2s2, 2p2. So in 3 answers, which is correct? So B is correct. B answer is correct. Why? Because 1s0 means the orbital is empty. Next orbital is filled with 2 electrons and another orbital is filled with. But Aufbau principle says first the electrons are filled with lower energy orbitals. So here the first one is empty. So B is correct. Okay. In which of the following Aufbau principle is violated? Means B answer is correct. Okay. Next one, Hunds rule. The orbitals of equal energy are occupied with one electron each before pairing of electrons start. The orbitals of equal energy are occupied with one electron. It means when we see all the orbitals, first one orbital is enters into the same energy orbitals. Next, the electron pairing with the first electron. Okay. So here carbon is taken as example. The electrons are 6 here. Electron configuration is 1s2, 2s2, 2p2. So first 2 electrons filled with a first 1s orbital, and second 2 orbitals also filled with a 2s orbitals. Next, how many electrons are remain here? 2. Only 6 is there. 2 is filled with the 1s orbital, and the second 2 electrons are filled with the 2s orbitals. So how many electrons remain here? 2 electrons. So these 2 electrons enters into the p subcell. So in the p subcell, how many orbitals are there? 3 orbitals are there, but not pairing in one orbital. First one is goes in a first orbital, and second one is goes another orbitals. Next we observe here, first one is showing upward direction, and second one also showing upward directions. Okay. So the first 4 electrons go into the 1s 2s orbitals, 1s orbital and 2s orbitals. The next 2 electrons go into 2p orbitals with having same pin. Same pin means same directions. One electron filled with one orbital, second one enters the second orbital with a same pin. First one shows upward direction, second one also shows upward direction. So one is a one orbital, second one is a one orbital, not pairing. Okay. So this is about the Hunds rule. Okay.